3. The major product of the following reaction. Major product of the following reaction. The major product of the following reaction. So the given reaction is CH3 bond C bond CH3 bond H bond CH bond Br bond CH3 treated with CH3 OH. Okay, so this is the reaction they have given and options. First option. So what is the first option means here? CH3 bond C bond CH3 double bond CH bond CH3. This is the first one. And second option. So what is the second option means here? CH3 bond CH3 bond H bond CH double bond CH2. CH2 double bond CH2. Okay. Now option C. So what is the option C means here? CH3 bond CH3 bond OCH3 bond CH2 bond CH3 is the one option. And D. So D. CH3 bond CH3 bond H bond CH bond OCH3 bond CH3. So this is the question. So this is the question they had given. Samhita and Ritu.
Sir, I think it's A.
Sir,
Huh?
I think it's C.
Both of you thinking it's A?
No, sir, I think it is C.
C, yeah.
Yeah, sure.
Samhita, what about your answer?
Sir, I think it's A.
The answer is C is the answer. It is a nucleophilic substitution reaction. So what is the answer means here? So answer is C. It is the nucleophilic substitution reaction. Okay. So simply they had given as here. Here secondary alkyl halide they had given. In the secondary alkyl halide they had given as the secondary alkyl halide is treated with the methanol. Okay. So methanol is strong nucleophile or weak nucleophile? Methanol.
Weak nucleophile, sir.
Weak nucleophile.
Strong system.
It is the strong nucleophile here. You remember one concept is there. Weak acid conjugated base is strong, it is there. Weak alcohols are weak acids. Weak acid, their conjugated base is here strong. That means they have a high tendency to replace the nucleophile here. Okay, now actually we can expect the answer is D. We can expect the answer is D. So in place of bromine, we can substitute the OCH3. But the given alkene is unsymmetrical. The given one is unsymmetrical one. The given one is unsymmetrical. They're asking the clearly major product. Okay, they're asking clearly major product. Okay, so simply I'll explain the mechanism here to make you clarity according to the question. So for example, first what they had given question here. So here means they had given means here they had given as CH3 bond CH3 H bond CH bond Br bond CH2 they had given. CH3 they had given. Bond CH3 they had given here. Okay. So this one it is treated with. So nucleophile. What is the nucleophile means? CH3OH. So because of his CH3OH is going to be ionized means here it forms as a H plus and CH3O minus is going to be formed. In this one, which one is the nucleophile means CH3O is the nucleophile. Okay. Now first if you remove the Br minus. If you remove the Br minus means CH3 bond H bond CH bond CH3. It forms as a secondary butyl carbocation. It forms as a secondary carbocation. According to the stability order. So which carbocation is more stable? According to the stability order, which carbocation is more stable, ma?
Third one.
Tertiary carbocation is more stable. Tertiary carbocation is more stable than secondary. Secondary is more stable than primary. Okay. So we discussed some reaction in the preparation of the haloalkanes. Which reaction? Markovnikov rule. Which reaction, ma? Markovnikov rule. So what is the Markovnikov rule? According to the Markovnikov rule, the negative ion is attaches to the carbon which is having the less number of hydrogen atoms in alkene. But there we had taken as a reactant is alkene. Okay. But in this one, we are doing as a nucleophilic substitution reaction. Okay. So we have two possibilities. What are the two possibilities means? At secondary carbon also we can substitute the OCH3. But what is the another possibility means? We can convert the secondary into tertiary. How we can convert the secondary into tertiary means by 1-2 shift. If you 1-2 shift means here 1,2 shift 1,2 shift. If 1,2 shift means here CH3 bond CH3 bond OCH3 bond CH2 bond CH3. Now if you OH attaches to this one means again you will get as one more product also CH3 bond CH3 H bond CH bond OCH3 bond CH3. Now if you compare this one is which one is the major product and which one is the minor product. So this one is we can call as a major product and this we can call as a minor product. So why we are calling as a major product? How we are going to explain the major product and minor product according in Markovnikov rule? How we are going to explain, man? Major product and minor product can be explained based on the stability of the carbocation only, na? In Markovnikov rule also. Is it right or not? Okay. Now, according to that one, what is the answer?
C only, sir.
C only the answer. Samita, you got the clarity?
Yes, sir.
Okay. So can I give one more question?
Yes.
It is look like this one only, ma. Okay. So one more question here. One more question they are asking. So what is another question? One more question they are asking here. So what is the question means here? The major product in the following conversion is the major product in the following conversation. Here. Okay, so they had given what they had given means here. So they had given structure is like this. Bond OCH3 bond CH double bond CH bond CH3 in presence of HBr. To make you confused, they had given as a excess of HBr and heat symbol question mark. Options. If you can expect the answer, option A. What is the option A? They had given 2019 mains question mark. This one is here. O bond CH3 bond CH bond beta bond CH2 bond CH3. Option B. What is option B means here? OH bond CH2 bond CH3. Option C. What's the question? Actually, it is the intermix question. It is there. Intermix question. It is there. Can I explain this question?
Sir, I have a rough guess if I could answer it.
Which one, ma?
B, sir.
B, yeah?
Yeah, sir, B.
What is B, ma? Somewhat correct only, Ritu. Somewhat correct only. That is only I'm telling that the question is interlinked with two concepts. Whatever the
No, sir.
question they have given.
Sir, the answer is C. I by mistakenly put the BR with the second carbon, it's with the first. The answer is C.
Answer is C. C also is not the answer.
What is the answer, sir?
Answer is D. Answer is D.
Got
Can I
it.
explain why the answer is D?
Yes, sir.
Okay. Actually, in this one, two concepts are there. What are the concepts means? This part is called as a ether linkage. This part is called as a ether linkage. So we have some question here. So what is the question we are having means ether chapter. Okay. So what is the exception case means? For example, when the ethers are reacts with hydrogen halide, when the ethers are reacts with hydrogen halide, especially anisolma, OCH3 group is there. If the OCH3 group is reacts with hydrogen bromide means in this one, so this one is converted into the phenol. Okay, so this one is converted into the phenol and bromine is going to be attached to the alkyl group. Then it becomes as a CH3Br. This is the one step. This is the one step reaction here. Okay, and what is the another step in this one only? It is that means here, first of all, they had given us some benzene ring. So benzene ring is attached with the CH double bond CH bond CH3. So this is the question here. Second step. Okay. So and this is also it is treated with the HBr. It is also example of the addition of addition of HBr here. The given reaction is example of the addition of HBr. Addition of HBr is the example of electrophilic addition reaction. Okay, electrophilic addition reaction. Okay, now
Doesn't the double bond break, sir?
it's not double bond is going to be break. In this one, we have to find out the reactivity. Which carbon is more reactive that we have to find out. Okay, which carbon atom it is more reactive that we have to find out here. Okay, actually, if you see means, so actually whatever the alkane it is given, that is unsymmetrical alkene only. Unsymmetrical alkyl only, but both the carbon atoms are having equal number of hydrogen atoms. While having the equal number of hydrogen atoms, which carbon is going to be attached to the Br means the carbon which is more reactive. Okay, so more reactive carbon is attached with the Br. Sir, how you knows? How you knows which carbon is more reactive means? Last time I hear while discussing GOC, electron displacement reactions. So there we studied about the reactivity also. Okay, there we studied reactivity also. And one more concept also clearly I told that. Okay, so benzyl carbon is more reactive. Benzyl carbon is more reactive. After that, allyl. After that, tertiary carbocation. After that, secondary. After that, primary. One statement I had given here. Okay, one segment I had given there. So benzyl carbon is more reactive than allyl. Allyl is more reactive than tertiary. So tertiary is more reactive than secondary. Secondary is more reactive than primary. Now you got the clarity. Still anyone you having doubt in that one? No, na? Okay. Now, according to that one, if you see means, so this carbon is called as a secondary carbon, but this carbon is called as a benzyl carbon. According to that one, bromine is going to be attached to the benzyl carbon. If the bromine is going to be attached to the benzyl carbon means, so this one is converted into CH bond Br bond CH2 bond CH2, and this one also it is converted into OH group. According to that one, what is the answer? Because of question, sir, why you had taken 2 moles of the HBr means in question clearly they mentioned. So what they mentioned here in question? So excess of HBr, they had taken. Okay, so excess of HBr means so alkoxy group, ether functional group also it's going to be converted into the alcohol. At the same time, alkene group is it undergoes to the electrophilic addition reaction. Okay, so that's why you get the answer is here option D. Anyone having doubt? Samvita, do you
Sir,
have
my
any?
only doubt is how did OH come, sir?
OH count is because of it is a alcohol ether chapter linkage it is there here. That is only first step. That is only I explain now. What I explained here. So when the ethers are reacts with hydrogen bromide, okay. So here anisole is reacts with the hydrogen bromide, means it forms as a phenol and alkyl bromide is going to be formed. If you take in place of hydrogen bromide, if you take hydrogen iodide also. If it is take hydrogen iodide, means hydrogen is going to be attached to the phenoxy group, that means OH, plus it is converted into methyl iodide. Okay, alcohols, phenols, ether chapter, we have a reaction with hydrogen iodide. There you will get this one. Okay, that interlink they had given to this question. Now we got the clarity, Samhita.
So the second compound reacts with HBr because it's a
Yes.
it's in a ether, so it is formed.
So it is forms as a OH.
Okay.
If they won't give, let us see one more condition also. If you see in here, if they won't give excess of HBr, if they won't give excess of HBr, only they are given only 1 mole of HBr, means answer is you will get as a is the answer. Now you got the point, Samhita?
So there's excess of HBr, that's why OH is also formed.
Yes, that's why it is forming as a OH also. Okay. Ritu got the clarity? Ritu, you got the clarity or not?
Yeah, sir, I got it.
One more question. Reactivity order we can complete. Two more questions are there, okay? What is another question they had given me here? One more question. No? What is another question? This very simple question only. CH bond Br, and they had given us alcoholic KOH as well as NaNH2. So what are the products? What are the products it is going to be for? CH2, CH3. You want options? Otherwise, without options, can you solve this question? It's very simple question only. Then I'll write the options also.
We'll try, sir. If we don't get, you give the options.
Okay, so first you try this one here. If you won't get me, then I'll give the options. But I'll give the options. Until that you can write, until that I can write the options here.
Sir, is the answer CH3, CH2, triple bond CH?
Right, ma'am. Answer is correct, Ritu. Answer is correct. Question is related to this one only, that's why I'm writing here. So can you try this one, this question also? Charlie, padko. Padko. Padko na. So try this question also.
Sir, I think OH is added to phenol and then Br and
Alcoholic KOH. Let's see, however, you told that Ritu, sorry, Samhita. So you solve the first question, question number 5.
yes, sir, it's D.
Okay, it's D. You got the answer because of alcoholic KOH also it act as a dehydrohalogenating agent and NaNH2 also it act as a dehydrohalogenating agent. Okay, now if you see means total how many halogens are there? 2 halogens are there. Okay, so by removal of the first halogen, so to make you clarity, I'll write here to make you understand, I'll write clear structure. CH3 bond, CH2 bond, C bond Br bond C here. Okay. Bond C bond H it will be there. So same question I'm writing CH and Br. Let us see. By taking with alcoholic KOH, we can remove the 1 HBr. We can remove 1 HBr. By removal of the 1 HBr, it forms as a 1 bond in between the carbon and carbon atom. 1 pi bond in between the carbon and carbon atom. And we have a 1 more halogen atom here. How we are going to be removed that one means by treating with sodamide. Okay, if this one also sodamide also it act as a dehydrohalogenating agent. Okay, so by using this one, if you remove this one also, 2 pi bonds are present in between the carbon. If 2 pi bonds and 1 sigma bond means you will get as a triple bond only na, in between the carbon. Samita?
Yes, sir.
So according to that one, what is the answer means? Option D is the correct answer. Now, in this one, they had given as a alcoholic KOH. Excess of alcoholic KOH and
Sir?
heat symbol they had given.
Sir, can I guess?
Guess ma? So otherwise first I'll write the options as after that you can guess.
Okay.
Okay. So it may be easy for you after seeing the option. Okay. Now let's see first option. So until writing the options here, you can try the answer. These are the options they had given. Any guess answer, Samita? Ritu?
Sir, I feel it is B, but at the same time, I'm confused with A also.
Sir, I think it's A.
You think it is A? Ma? Uh, Elimination reaction, do you have any idea? First of all, I want to ask one question. Elimination reaction.
Yes, sir. When we eliminate a hydrogen from the compound or any other compound, we get a
Very
double
good.
or
So there
triple.
we are studying about the Saint-Jeff rule. One Saint-Jeff rule it is there. Did you remember? According to the Saint-Jeff rule, the alkene which is attaches with the more number of alkyl groups, that it becomes as a major product. Do you have any idea? Do you have any idea about that one?
Yes.
Okay. Now, so you are telling that, so actually this is the question. Same one only I'm going to make you clarity. I'm writing like this here. This one is pH. This one is alkyl group. Here Br it is there. Next this one. After that, here one more Br it is there. And this one and this one. So this only na. Let us see. We have a two possibilities. Let us see. First, I'm talking this bromine atom. Okay, we have a two possibilities. So we can remove the bromine from these carbon atom and these carbon atom also. Okay, if you remove that one means in which direction? For example, let us consider it as a first carbon atom. Let us consider it as a second carbon atom. From where, if you remove the hydrogen atom, then it becomes as a more stable. That you can tell me first. If you find out the logic means, you'll get the answer. Now my question is, according to the Saint-Jeff rule, we have two possibilities to remove the bromine atom, hydrogen bromide. I already give the numbering also. We have a first carbon atom and second carbon. Here also one hydrogen atom is there. And here also one hydrogen atom it is there. From where we can remove the hydrogen atom. If you remove that one means which one it becomes as a more stable. That is my question. Can I explain here? Two possibilities. 5, 6. If you remove the hydrogen from the first carbon atom, double bond is formed here. Double bond is formed here. Br it will be like that only. This will be like that only. Okay. Now let us see. The alkene is attaches with this side one alkyl group it is there, and this side only one alkyl group. That means it is attaches with the two alkyl group. And second possibility we are checking. What is the second possibility means? If you remove the bromine atom from the second carbon atom, if you remove the bromine from the second carbon atom, okay, if you remove the bromine from the second carbon atom means double bond is formed here, okay, and this carbon is attaches with the bromine. This carbon is attaches with the bromine. Now, let us check it out. This is the alkene means. So here we have the number of alkyl groups. Here also one alkyl group is there. This one also one alkyl group. This one also it is the one alkyl group. That means the alkene is attaches with the three neighboring alkyl group. Okay. So what is the statement according to the Saint-Jeff rule? The number of alkyl groups are increases. Their stability also is going to be increases. Now we got the clarity, both of you, Ritu and Samhita. Both of you got the clarity? Samhita,
Yeah.
you got the clarity?
Yes,
Samhita.
sir.
Okay. Now, so which one is having this kind of structure? Second part. Which one is having this kind of structure? First, you can check it out.
Dina,
Here.
sir.
Okay. So we have a C also it is having similar structure, and D also it is having similar structure. Okay. Now in C and D, so which one is the answer that we have to find out? Okay. So they're asking stability. Which one is the more stable means here. Here if you see means first one is we got the clarity. And second one we have to check it out means here. Second one is one side cis isomer it is there. Another one is having the trans alkene. In cis alkene and trans alkene, which one is more stable?
I think it's trans, right?
Trans is the more very good, Samhita. So trans alkene is the more stable. Sir, how you are telling the trans alkene is the more stable means both the identical atoms are present at opposite direction means it becomes as a more stable. Okay. Now, which one is contains the trans here? This one only, na?
C, sir.
Okay. C or D? This is the cisma. Let us see here also one alkyl group. for second alkene group I'm talking here. This is a second double bond. So this is also second double bond here. In second double bond, if you observe means, so two alkyl groups are present at same side means thus we can call as a Cs. In this one, what happened here? Alkyl groups are present at opposite direction. When the alkyl groups are present at opposite direction means that we can call as a trans. So in these two, which one is the major product? D or C?
Sir, how is the second one, sorry, D trans?
Trans bar. Let us see. I'll write as a butene structure. CH3 bond, CH double bond, CH bond, CH3. Is it right? It is 2-butene. 2-butene means we can write like this also. That is correct or not? Line representation. Methyl group. And same 2-butene also we can write like this. You can write like this also. Now in this one, two methyl groups are present at same side. If two methyl groups are present at same side, means that we can call as a cis. If two methyl groups are present at opposite side, means that we can call as a trans. Okay. So second double bond. So that means this part. If you observe which one is cis and which one is the trans, by seeing the structure only we can say. Samita, got it?
Yes, sir.
Yeah. According to that one, which one is there? Which one is more stable? That it becomes as a major product. The major product and minor product can be explained the stability of the products are here. Okay. According to that one, what is the answer? D.
D.
D, sir.
Now you got the clarity.
Yes, sir.
Yes, sir.
Whatever the questions all we discussed, all these are the 2019 JEE questions only. Okay. So first you go through the concepts and first you practice simple questions. Sir, from where you will get as a simple questions means some MTG questions are there and NCERT textbook backside some conversions are there. I think so. We all are using Academy books. Is it right?
Yes, sir.
Okay. Academy textbook backside they had given some conversions. See, please first you practice that one, then only you can get the clarity. Because of all these are the conversion based questions. Now, almost all we had seen some 5 questions. All 5 to 6 questions are conversion based only in JEE. Even in NEET also they're asking conversion based questions only. Some questions are theoretical based questions they're asking. Samhita, you got my point or not?
Yes, sir.
Okay, so that's why better to practice more number of questions. Okay. So then, so remaining part we'll discuss on Monday. Yeah. So thank
Okay,
you
sir.
all.
Sir,
Thank you.
could you
Ama.
solve some NEET questions also, sir, like from previous papers?
Yeah, sure, ma. Definitely. Okay. So do you
Okay.
have any need previous year questions? Do you have any MTG previous year papers?
Yeah, sir, I have MTG ones. I'll share it to you.
Okay, no problem. Okay, so first you do one thing, you solve the questions here. If you're having any doubtful question, means immediately forward to me. So that question we'll discuss in the class.
Okay, sir.
Okay, then fine. We'll continue in the next class.
Thank you, sir.
You're welcome.